Hello, everybody. I'm here to do a quick sub 5 minute review of the product and quotient rules. So these aren't really difficult rules to apply, but they can sometimes, and especially the quotient rule, they can sometimes be a little bit difficult to remember. But so here I just have, some basic examples. First, I can talk about the product rule. So U and V here is a little bit strange of a way of formatting this, but U and V are both functions of x. So a different way to be represent this would be like f of x times g of x. Just two functions of x multiplied by each other. You do one of them times the derivative of the other plus the derivative of the first one times the other. So u times dv dx plus v du dx. So you can see some examples. Sine of x times cosine of x. You do you do derivative of sine times cosine. So derivative of sine of x is just cosine of x times cosine of x is cosine squared plus sine of x times the derivative of cosine of x, which is negative sine of x. So negative sine squared of x. So cosine squared minus sine squared. X e to the x. Here I plugged in 0, but first you would take the derivative of x times e to the x, so that's just e to the x, plus the derivative of e to the x is just e to the x times x, so it's e to the x plus x e to the x. Another way you can write that is you can write, e to the x times 1 plus x. So if you plug in 0 here, it'll be e to the 0 times 1 plus 0. This is just 1 times 1. You can see a few other examples here. X squared cosine x squared. This uses a little bit of chain rule, which I covered last time. You can see that here with the x squared coming out. X tan of x. The derivative tangent of x, which you should remember, is secant squared of x. And yeah, you can see a few other examples here if you want to keep looking. So, quotient rule. This one, same thing. In this example, this also doesn't show it completely, but if it's a function of x divided by another function of x. So in this example, it'll be u over v. And so the way to remember this that I remember and that my calculus teacher, Mr. Milanovic, kind of coined, or I'm not sure if he coined it, but it's a very easy way to remember it. It's low d high minus high d low over low low. And so what that means is that you take the low, so the denominator, times d high is the derivative of high of the numerator, minus high, so the numerator right here, times the derivative of low, d low, over low low, which is low squared, the denominator squared. So some examples here you can see. I won't word these out exactly because these can get very complex a lot of the time. But something you should know is that these solutions will always be consistent with all of the other rules. So x cubed is equal to x to the fifth over x squared, and you can write it out like that. And if you do the rule with the quotient rule, you get 3x squared, which is the exact same thing you'd get if you just did the power rule. Same thing with the product rule. X secant of x can be written as x over cosine of x because of what secant of x is. And if you do the derivative of that, and when you're done, cosine over cosine squared is secant x sine over cosine squared is x tangent x secant x. And this is equal to what you do if you did the product rule. So remember, they will always be consistent, and make sure to know that when you're applying the rules, so you can use a variety of tactics to differentiate your functions.